Alright, in this video I'm going to show you two of the more challenging applications of the Pythagorean Theorem that you might see on a test, on the ACT, on our map at the end of the year. But these are asking us, these kinds of questions are asking us to take the basic idea that we understand about the Pythagorean Theorem, that it's a squared plus b squared equals c squared, that it applies to right triangles, so we need to know the characteristics of a right triangle. What is the longest leg always? Those kinds of ideas. And we need to synthesize those all together to answer these questions. While they look different, they don't look like the problems from the video where we derive the Pythagorean theorem and put it into practice. They do use the exact same ideas. So we can't be baffled by them. We can't let our confidence get shot down because of them. We just need to remember that we do understand the Pythagorean theorem, and then now we just need to put it into practice. So one of these problems that you will see often is that you will be told the hypotenuse of a triangle, let's see, the hypotenuse of a triangle is the square root of 61. Okay? So the hypotenuse of a triangle is 61. And no, they should be more specific. The hypotenuse of a right triangle is the square root of 61. So you're sitting here going, great, what am I supposed to do? Okay, well, most likely the question will be, what are the side lengths of that triangle? What are its side lengths? And you're going, well, everything Mr. Zitzer has told me is that if I'm doing a Pythagorean theorem problem, I'm getting two of the side lengths and trying to find the third. Well, this problem is a little bit different, and it requires us to work backwards. We do need some number sense. We do probably need to know our perfect squares. Most likely a question like this will ask you for a whole number answer, not decimal answers, but whole number answers. Okay, so the first place we're going to start is we're going to put our Pythagorean theorem up here again. Because what we're trying to do is we're trying to get back to this equation, moving backwards. Because we are given the answer right now. We know that C equals, actually let's flip this one. We know that C equals the square root of 61. Okay, so the square root of 61 equals C. Alright, well now let's work backwards. C is the length of the hypotenuse. We want the area of the square made off of that hypotenuse because that's what C squared is. So if we're working backwards, we're going to want to go back up to C squared. Okay, so that means if we do the square root of 61 squared, this is 61. If you don't believe me, put it in your calculator. Square root of 61 times the square root of 61 is just 61. Okay? Well, now what we need to do is just a little bit of guessing and checking. This requires us to have some number sense. Maybe your teacher will have the square root chart up, the perfect square charts up in their room. I know for my class that I'll have the square root chart up until the time when we're taking our math test at the end of the year or EOCs at the end of the year. And by then you'll either have had to memorize them or maybe your number sense will just have increased a little bit. So I'm looking for two perfect squares that are going to add up to 61. And I know that that's going to be 36 and 25. Okay? I remember in class a lot, students are asking, well, how do you know that? A lot of it's just guessing and checking. It's looking at my perfect square chart and going, all right, which two of these numbers, after I squared them, are going to be, we can get added up to 61. Okay? I know 25 and 36 add up to 61, and they have perfect squares. Okay? So the square root of 36 is 6, and the square root of 25 is 5. So I know that the side lengths for a triangle with the hypotenuse of the square root of 61 have to be 6 and 5. Could I have gotten decimal answers? Yes, I could have. But most likely a question like this will ask for whole number answers. So these are right now these are our two options. Some of them might have multiple. If the answer was the square root of 50, there are multiple ways to get the square root of 50. You could do 25 and 25, and both of your side lengths are 5. You could do 49 and 1, and then one of your side lengths is 7, the other one is 1. So it's a lot of guessing and checking. It's a skill that you only get better with practice. But this is a very common application problem. Nothing in here do we not already know. Nothing in here is new. Nothing in here is super tricky. It's going, okay, I understand the Pythagorean Theorem. I know that if they give me the square root of 61, that's the answer for C. Let's work our way backwards, guessing and checking if we need to find out what A and B are. Okay? So let's do one more challenge problem that has a little bit more work in it, but again isn't too tricky. Let's see. This is it, so we're going to have to find it first though. Here it is. Alright, let me blow this one up so that we can see it really well. Magic. Alright, this is another common problem that you'll see. This is really trying to push us. And I know it's trying to push us, but it isn't anything different than what we already know. Okay? It's just asking us to apply what we know. It's taking it one step further. It's challenging us to apply what we know about square roots, the Pythagorean Theorem, and right triangles, and put that into practice. Okay? And we should be wanting to accept that challenge and to work on a problem a little more difficult like this. So, this problem says a triangle has side lengths of the square root of 15 and the square root of 22. What is the shortest possible leg of that triangle? What is the longest possible leg? Okay? It's saying these are two side lengths. We're not telling you whether they're hypotenuse or their legs. We're not telling you any of that. We just want to know what could be the longest side length, what could be the shortest. So I got to draw two pictures. There's no way I'm going to figure this out without drawing two pictures. So here's my first triangle. Here's my second triangle. These are not very good right triangles. But I'm no artiste. Alright, so if they're asking us for the shortest possible leg first, that means one of our legs, one of our side lengths has to be the longest. And in a right triangle, the hypotenuse is always the longest. So, of the two numbers we have, the square root of 22 is bigger. So that's going to be my hypotenuse. It has to be my hypotenuse. Okay? Because if we're looking for the shortest leg, that means that the other length that we're looking for is shorter than any one we were given. And since the square root of 22 is the biggest side length we were given, it must be the hypotenuse. So I'm going to label that C. We're going to say the square root of 15 is A, and then we don't know what B is. Okay? Let's go over to the other question. The other question says, what is the longest possible side length? Okay, well that means that if we're looking for the longest one, that again has to be the hypotenuse. That has to be C. Because these two legs that we were given must be smaller than the one we're trying to find. So the square root of 15 will be A, and the square root of 22 will be B. And now all we need to do is work the problems out, and we'll get two answers. This is no different than the video that I did on deriving the Pythagorean Theorem, and I showed you the two application problems, the two practice problems. One had you find C, one had you find A or B. This is the same thing, but instead of giving you two separate problems, they gave you two side lengths and told you to draw your own pictures. Okay, so let's plug these in. The square root of 15 squared, so we know our equation is, A squared plus B squared equals C squared. So I'm going to plug my values into that formula. So I have the square root of 15 squared plus B squared equals the square root of 22 squared. Okay, I know this is hard to wrap your head around, but if you don't believe me, check it in the calculator. If I take the square root of 15 and times it by the square root of 15, I just get 15. Because that is, 15 times 15 is the square root of 225. And if you look in your calculator or you look at your perfect square chart, the square root of 225 is actually 15. Okay, so I don't want to be seeing with problems like this that you start writing 225 down here. The square root of 15 squared is just 15. Okay, plus b squared equals 22. Because again, the square root of 22 squared is 22. They put these square root signs up here to just make it more challenging. Okay, but it's not too difficult if you, one, use your calculator to help you out, but two, if you remember what we've talked about square roots. Okay, so now again, all I gotta do is subtract my 15 from both sides because I want b squared by itself. And I have b squared equals 7. Now you take the square root of both of those so I can figure out what b is. And the square root of 7, so b would equal the square root of 7, or a little more specifically, actually probably less specifically, it is roughly 2.6. Okay. On a test, especially if it's a constructive response question, if you left it as the square root of 7, I would not have a problem with that. If you want to write 2.6, that's fine too. But notice, the square root of 7 is less than the square root of 15 and less than the square root of 22. Okay, so that is the shortest leg we could have found. Alright, now let's go over to this other problem and set this up correctly. So we have the square root of 15 squared plus the square root of 22 squared equals c squared. Again, the square root of 15 squared is just 15. The square root of 22 squared is just 22. Add them together and we get 37 equals c squared. I'm going to take the square root of both of these. So my answer is the square root of 37 or 6.1, I think. Let's check in the calculator. Yep, roughly 6.1. Okay, again, look at this problem. A lot of times you're going to say, well, Mr. Zitzer, 6.1 is not bigger than 15 and 22. You're right. 6.1 is not bigger than 15 and 22. But our side lengths aren't 15 and 22. Our side lengths are the square root of 15, which is less than 4. It's 3.87. And the square root of 22, which is less than 5, more approximately 4.69. So 6.1 is still bigger than both of those. Also, if we just look at them in the square root form, the square root of 37 is bigger than the square root of 22 and the square root of 15. So our two side lengths are 2.6 and 6.1. That's our shortest and our longest. So the square root of 37 here and the square root of 7 here. Okay, here's our two separate triangles with their possible side lengths. Alright, again, these are just application problems. These are just putting what we know into practice in a different way. Synthesizing ideas, putting all the ideas that we've talked about in together, into place, into one problem. Okay? So I hope you don't get too discouraged by something that's a little more challenging like this, but can actually sit down and go, I know what I'm doing, I know the Pythagorean theorem, I just need to put that into practice. Alright, again, there'll be a couple more videos up. The last one we're probably going to do is determining whether something actually is a right triangle or not. So look out for that one next.